This video will pick up from the Decentralized1 video and show the solution for the distributor and the factory in this case. So in the previous video, we saw that the wholesaler's solution was to use an order quantity of 903 and a reorder point of 2018. Now we need to see how the distributor would respond. So to do so, we need to enter their total cost. For the distributor, its expected order cycles per year are going to be based on its order multiple and the wholesaler's order quantity. So this would be the annual demand divided by the wholesaler or distributor order multiple times the wholesaler order quantity. 3 is just a starting value right now. But basically what this means is that the distributor is going to order 3 times 903 from the factory each time it orders. And so it's going to triple the wholesaler's typical order with the factory. Now, we'll see if 3 or 2 or 1 or some other integer becomes the actual solution when we solve the model. If you look here at the expected orders per year for the wholesaler, it's 47, but the orders per year for the distributor is effectively 1/3 of that because the order multiple is 3. If we change the order multiple to 2 temporarily, we see that now the orders per year for the wholesaler is 47. The orders per year for the distributor is half of that. So you can see how the orders per year changes with the order multiple. I'll change it back to 3. So then the ordering cost per year is the order cycles per year for the distributor times the distributor's fixed ordering cost. All right, now we move on to the holding cost for the distributor. So the holding cost for the distributor is going to be similar, except requiring an adjustment for the multiple that the distributor is using. So if we look at the wholesaler's cost, it is 0.5 times Q, and that's also true for the distributor. But remember that Q as an order quantity is multiplied times the distributor's order multiple. But we're going to subtract 1 from that amount, because what we'll see is that the first Q units are never going to be held by the distributor. They'll just be passed directly on to the wholesaler. And so then the distributor will only hold what's left. So then the average inventory is multiplied by the distributor's annual holding cost. The total inventory costs for the distributor are the ordering costs plus the holding cost. Now, how do we find the solution for the distributor? It's important to note here that we already solved the model for the wholesaler, so those solutions need to be correct in the model. What we can do is do this by trial and error. I'm just going to make a small table out here that has potential order multiples for the distributor and the total cost associated with those multiples. So we'll just start at 1. So let's enter 1 for the distributor order multiple. One important thing we notice when we enter 1 is there's no holding cost at the distributor. It just receives units from the factory and just passes them directly on to the wholesaler. And this is a nice solution in a lot of ways in terms of the bullwhip effect, because we don't hold any inventory. So we see the total cost in that case is 16 545, 65. Okay, and so we've tested 1 as a potential order multiple. Let's test 2. When we enter 2, the total annual inventory costs for the distributor go down to $13,688.95. So we'd prefer 2 in this case to 1 as an order multiple for the distributor. What if we enter 3? Well, at 3, the cost went back up. So when the costs go back up, when moving from 2 to 3 for the multiple, then we can be sure that the multiple of 2 is the best solution, because it won't come back, the cost won't come back down if we keep testing more values. So what we want to do is go ahead and enter 2 for the multiple here. Okay, so now we're ready to look at the factory. And again, important to note that these are the best solutions for the other 2 parties in the supply chain. So let's examine the factory. What is the number of setups per year for the factory? So if we look at what's happening here, each time the distributor orders, they're going to order 903 times 2. So the factory might further multiply that order, which is basically 1,800. They might further multiply that order and produce a larger batch, potentially. So what happens is that the expected cycles per year for the factory is the annual demand, but then that would be divided by the factory multiple times the distributor multiple times the wholesaler's order quantity. The factory may produce fewer batches per year. In fact, we see that here. If the distributor orders are 23.64 per year, and the factory chooses a multiple of 3, they're going to only produce 1/3 as many batches as there are orders for the distributor. So we would multiply this times the factory's fixed ordering cost. Now the average inventory cost. If we think about the way we've calculated average inventory, the average inventory, the order quantity for the distributor is ND times Q. But then that will be further multiplied by the factory's order quantity. Now, we reduce the factory's multiple by 1 because for the first multiple, the first ND times Q units, the factory is just going to pass that directly on to the distributor. And so then we would multiply this times the factory unit holding cost. And let's do that here. We'll multiply the inventory separately times the holding cost. And so the total inventory costs for the factory are the ordering cost plus the holding cost. And we'll go ahead and add together the total supply chain cost. Wholesaler plus distributor plus factory. And those will be useful when it comes to analyzing the centralized mode versus this decentralized mode. Now, we already found that 2 was the best multiple for the distributor. And so when it comes to the factory, we need to similarly test different potential quantities. So let's test multiples of starting with 1, 2, and 3. And we'll note the total cost. So let's start at 1. And at 1, we see the factory's total cost is $11,818.32. If we increase that to 2, the factory's total inventory cost increase. And so once it increases, as we move to higher order multiples, we're not going to see any further decreases. So really the solution would be 1 because that's going to be the lowest cost. So we want to change this to 1. And so that gives us our optimal solution, in this case, for the wholesaler, distributor, and factory. If we look at the textbook, there's a diagram here of the inventory levels with the multiple of 2 for the wholesaler, which is what we have in this case. So the factory is going to produce first, and then